Okay, so let's kick this off with giving you the formula for the standard error of the mean, which is it's equal to variance over n square root of all that, which is the same as saying it's the standard deviation over square root of n, because standard deviation is square root of the variance. And so, first of all, let's talk about why SEM increases as the standard deviation increases, so as the dispersion of the sample increases. And so let's just look at an example here. So let's imagine we've got two different samples, and they've each got two different populations, and they've each got a population mean of 50. So in both cases, population mean is 50. And in the first population I've got here, I've got a load of samples, 49, 48, 47, 46, 45, 51, 52, 53, 54, 55. Okay, and then we're going to take a random sample from here. So let's imagine we've got this one, this one, this one, and so the sample mean of that, these blue ones, is going to be 47. Or if we take a different random sample, take a different random sample of, I don't know, like these guys, then the population mean is going to be 53. So those are each 3 away from the true population mean. Now let's imagine we've got a second population which is much more spread out. So if we've got, so in here each of my measurements are 10 apart instead of just 1 apart. So these are all my different measurements here. Okay, so the standard deviation of this population is much higher than the standard deviation of that population, but the population mean is the same. So now let's do the same thing. So let's say, I don't know, we've got, here's a sample. So the sample mean of that is going to be 40. Or for these guys, so these are at the same rankings in the population as the ones I just did there. So here the sample mean is going to be 80. So you can see that here the distance between these sample means and the population mean is much bigger for the second sample than for the first sample. And so we can be much less confident with this bigger spread of measurements that the sample mean we get is close to the population mean than with this small dispersion of measurements around the population mean. So if all the different measurements are close together in general, then the sample means are going to give you a better idea of the population mean than if they're more spread out. So that's why we've got the standard deviation here in the top of the formula for the standard error of the mean. And now my second point here is that the standard error of the mean decreases as sample size, so that's our n here, increases. So this is the idea that the more samples you've taken, the bigger your sample, then the closer your sample mean is going to be to the true population mean. Okay, so let's take this data set here that I've taken from a random number generator online, and here's the population mean, 53.5, and I'm just going to take a few random samples from this and we'll see what happens. So here we've got the measurements go from 0 to 100 and our population mean is 53.5. There she is. Okay. So then first of all, how about, so there are 20 measurements in my population. So first of all, let's take sample size of 2. So let's take this first one. So if my first sample is these 2 measurements here, then the sample mean is 84. If I take these 2, sample mean is 59. This is just at random. So you can see some of these are quite close to the population mean, but some of them are quite far away, like this 11 here. Okay, so let's mark, should we mark these on the number line there? So 84. Gonna be here somewhere. 59, quite close. 48. Quite close. 55.5, very close. 11 all the way down here. Okay, so we've got some very far away, some that are quite good estimates. And how about if we take now sample size of 5. So then for here the sample means are like this. So let's remark those on as well in blue. So you can see this cluster here from the slightly bigger samples are quite much closer to the true population mean than this big spread with the smaller sample size. And then finally, let's just do one more. Let's have a sample size of 10. So then we've got 56.3 and 50.7. So that's even better. And so on. So this effect is true. So you're less sensitive to having some extreme values the bigger your sample size is. So to conclude, your standard deviation of the mean is smaller, so you can be more confident that your sample mean is close to your population mean as the sample size gets bigger. So that's why we've got the square root of the population size. Don't worry why it's the square root. It's square root because we're looking at the variance. But anyway, as your population size gets bigger, we can be more confident of that our sample mean is similar to our population mean.